This week's video is going to be a bit different. I tend to pick one machine to restore and repair or upgrade, but my mail has piled up for a bit too long. And this week I'm working on a large project that is going to take a while to finish. So instead of piling up more mail this week, let's play with it and make a video. The pile I've got is a mix of vintage computer stuff and some tools to make better videos, and a project from my favorite sponsor PCB. Let's start with the largest box. This is a donation from viewer David in Virginia. So hello to my viewers in Virginia. David used to work at Radio Shack in the 90s. And this machine was used to connect to the Verizon wireless, then Bell Atlantic cellular phone activation system via modem. Better get that box out of the way. I'm gonna let you guys guess what this is while I unwrap it. So you've got about 30 seconds to make your guess. And I'm gonna start with a keyboard to give you a clue. I guess the first clue is that I think these machines were released in 1990. And here's the keyboard. There's no logo on top of it. So that should be a pretty tough guess. And the machine is about the size of a regular CRT display. So that's your next clue. I love unboxing my mail because I do it quite rarely. So it feels kind of like Christmas. And I have to say it has been really well packed. That is always a joy to see. The box didn't have any dents, so it seems to have been well handled by the shipping company too. And there you have it, a DEC VT420. I also got a bunch of adapters and cables, and I'm obviously gonna have to do some reading, because to be honest, I don't know much about these machines. In fact, I have not used one since I last visited a public library as a teenager. But I have always been very curious about these machines. And now I finally get to explore them. Yeah, now I remember. So David kindly enough also included an OpenGear ACM 5508-2M serial port server. So I'm gonna have to do some reading. So this system was known as the Remote Order Entry System Terminal and was phased out when they deployed a website to do the task instead. I'm really looking forward to doing some research and making a video about this machine. So thank you David for the generous donation. If you guys have any suggestions for a fun project to do with this machine, please share them below. And I'm happy to report that the machine has arrived safely with no cracks or dents. It has yellowed a bit, so we are going to restore it before we start playing with it. Well, there isn't much we can do with it offline, but we can at least turn it on and see if it still works. And yes, it does. Copyright 1989, Digital Equipment Corporation, VT420 OK. So we can do some settings, but there really isn't much we can do with an offline terminal. But it has a really cool amber display. So let's move to the next item. Next we have an LM246MS microscope that was kindly gifted to the channel by Link Micro. And it's gonna come in very handy in a few minutes. But let's have a look inside the box. If I can get this box on camera, that is. That's a rare sight nowadays. And then we have the microscope. And by the looks of it, it has the microscope built into the display. I was expecting some assembly. So then we have a base plate with some lights. And I'm just gonna guess instead of reading the manual. So pretty sure this rod mounts here. And then this piece should probably sit like this. Yeah, this looks simple enough to guess. So the microscope probably mounts here. Okay, I think I managed to hook it up without reading the manual. And the display seems to be working. Let me grab a PCB. Okay, so here's the dead test cartridge. Let's see if we can get it in focus. Now I see. Here's a focus ring. So that means we can move in a bit closer. I wonder how close. Yeah, that is looking good. This is definitely useful. Okay, so we've got an HDMI cable here included in the package. So let me hook it up with HDMI and see if I can make it a bit more useful for the stuff I tend to do. And yes, that is way more useful for sure. So that's what a 32-inch resistor looks like. Or is it 34? I don't remember. But that is a huge resistor. And I just connected the cables, so I didn't have to do any settings. And it just worked right out of the box. And there was also a memory card included. So I guess I will be able to record when I solder. And if all goes well, you should see some improvement when I do some soldering work on this channel. And I also got a couple of lenses here. So I guess I'll read the manual and do some tests. And then I'll try it out on a proper video. But this is definitely looking good. Perhaps we'll try it some more in a minute, after I have unboxed the projects. And if you're interested in one of these, you will find links in the description below. And the next item I had to pay for myself, unfortunately. So Nikon, if you're watching this, please start sending free stuff to me. So this is a Nikkor lens, and it's a 60mm micro AFS-N. And I held off buying one of these because they are silly expensive. But luckily I finally managed to find a used one for an incredible price. So when I do some work on PCBs, I use this thing here on a 24mm Nikkor lens. And this is a 10x diopter. And it has worked out quite well, but I think this might be a significant improvement. Let's compare them in a minute, after we have unboxed a couple of boards. Next we have something that I have been looking for a very long time. This is an ABIT VP6, a dual socket 370 board that will take two 1 GHz Pentium 3s. It's sort of the big brother of the more famous BP6, I guess. I had one of these boards back in the day when they were new, but only for a few years because at the time the capacitor plague had just started. And my board only lasted for a few years, just like every other VP6 board. This board is going to be a part of a recreation video of my system from 2000. I still need to find an identical case that I had back then. But when that is sorted, I will make a video and I will tell you everything about this awesome board. I guess we could try that macro lens and have a look at the condition of these caps. So for comparison, this is the diopter on the 24mm lens. And I guess the main issue here is the depth of field. So if the text is in focus on the board, you can't really see much of this cap here. And if I refocus to the top of the cap, you can't see the board anymore. That cap actually looks a bit weird. That cap looks like it has a hole on top of it. But it doesn't look like a typical bulging cap. That looks more like mechanical damage. Maybe someone was stacking these boards. And this is the real macro lens. And well, I'd say the image quality is way better than the diopter. And the magnification is much higher. But unfortunately we still have the same problem. So now we can read the text on the board. But we can't see what the text is on this chip here. And that chip is just 2mm off the board. So the DOF is less than 2mm. And with this chip in focus, we can't really read the text on the board anymore. And the cap up here is just completely blown out. So if we move the focus up to the cap, that sure does look like a hole, doesn't it? Well, as you can see, we can't see anything on the board at all. So that was a fail. This thing is going back on eBay. At least I got it for cheap, so I'll probably get my money back. Well, I just realized that we could and should take this too far. So I have now mounted the diopter on the macro lens, and everything is huge, but if we focus on the text on the motherboard, we can't read what's on these resistors anymore. But how about that hole? Let's have a closer look. Yeah, that is definitely a hole on top of that cap. Check this out. How the heck did this happen? Never seen this before. That's definitely a first. When these blow, they tend to open up and not make a hole. Huh. And next up we have a VC600D clamp meter, kindly gifted to the channel by VenLab. This could be very useful for checking currents without having to remove or desolder cables. So let's have a look inside. And a decent manual again. That is really not a common sight nowadays. And it came in this pouch. Oh, that is huge. And batteries included. That is a large clamp. So let's try it out and get inside the battery compartment. I really like it when they include batteries. I remember as a kid, sometimes I got some toys for Christmas, but no batteries included. And then I had to wait for at least one day before I could actually play with my toys. So let's peel this thing here off. Let's have a look at the probes. They were actually quite soft. So that's not too bad. That's actually better than expected. Yeah, those are decent probes. These are way nicer than the probes I got with my Unities. Not quite as nice as my more expensive probes, but definitely decent. Oh man, this thing here goes up to 1000 amps. This is actually way more than I will ever need. So how do we try this thing out? Oh, silly me, I put the batteries in the wrong way around. What was I thinking, talking childhood memories? Okay, let's see how much current that miniscribe needs. That thing should be power hungry enough. And it seems to draw about 700 milliamps. And the next item is some PCBs from my favorite sponsor, PCB Way. So these are XT-IDE cards. And there are, of course, tons of different cards available nowadays. And these are designed by Glitchworks. And the thing about these cards here is that it's only using through-hole components. So I guess this version here is the beginner-friendly version. And as always, these look awesome. And apparently these are Rev 4. And if you want to play along and build one of these up, I will put a link down below. And I found these on their shared projects page. So the link I will provide will take you to the shared projects page. And by the way, if you are using the provided link, you will also find a bill of material. And these boards, by the way, are very clearly marked on the silk screen. So these two are 10K resistors. And then we have a bunch of 0.1 microfarad caps. And since all the ceramic caps have the same value on this board, they are just marked with a C on the PCB. And aside from those 10K resistors, we also have these two 470 ohm resistors up here. And next we have two resistor packs, like so. I'd better do some soldering before it gets too messy on this side of the board. By the way, I switched to 0.38 solder from 0.5 a couple of months ago. And I absolutely love this stuff. One wouldn't think it would make such a huge difference, but it really does. I haven't touched my 0.5 solder since I tried this stuff out. And for comparison, I'm using my 24mm lens with the diopter now, but I will switch in a minute. Okay, let's get some sockets on that board. Unfortunately, I can't use the microscope to record video quite yet. A memory card was included, but unfortunately I don't have a reader for a card with that size. Okay, that was the last socket. So now we need to install 2 switch blocks for switch 1 and switch 2. And we're almost done here. So let's install some pin headers. One pin header down here for an external LED. Let's not forget C12, the only electrolytic capacitor on this board. And D1 up here is just a regular green LED. I also decided to try out the longest lens for the microscope. And I have to say, I'm pretty impressed. I think it's doing some wizardry with a very high ISO, because there is some distortion in the colors. But that doesn't really matter when we work on boards. So impressive as it is, this magnification is not really usable for soldering. This is more for trying to find micro cracks, or perhaps tiny holes in capacitors. Let's bring out that VP6 again. And check this out, how cool is this? So with this kind of magnification, we can actually see that the hole here hasn't quite punched through the shell. There is also some more damage here. So I think this motherboard has been stacked with another motherboard on top of it. So for microscopic inspections, this crazy lens here is very useful. Now let's get back on track. So for a soldering job, this lens is way better. It gives much less magnification, but this is a more useful view. And the working distance is excellent with this lens. So I have plenty of room to work on the board underneath the camera. So check out the working distance here. That is massive. Even with this really high PCB holder, I still have plenty of working space here. And I can still fit an entire IDE connector on the screen. That is perfect. And it has 2 of these LED lights built in. And they turned out to be really useful. So if you're planning to use this board with a compact flash adapter, you would probably go with these angled pin headers like this one. But I'm going to use this card with a regular IDE cable. So I'm gonna go with straight pin headers like so. Okay, so let's solder just 1 pin on each pin header first. And make sure they are nice and straight and sits flush on the board. And they weren't, so I'm glad I checked. So I think this is the last part that we need to solder. So I'm gonna skip ahead here. Okay, board cleaned up. Let's get some chips in those sockets. And as you can see, the solder mask will tell you what chip goes where. So you don't really need any instructions for these boards. That was the last logic chip. Unfortunately, this is as far as we can take this today, because the EEPROMs were out of stock and had some really silly lead times. So I'm gonna have to put this card aside until my 28C64 arrives. Okay, so I did an inspection of the VP6 board, and unfortunately I found some minor damage. So this component here has been ripped off, and this is very close to where the heatsink latches onto the socket. So my guess is that this component here has been ripped off when someone was mounting a CPU in the socket. Let me move in a bit closer. Okay, so you can clearly see that this component here has been ripped off, and it's completely missing. And this component here too has some damage, but it kind of looks like it has fried. And BC48 here doesn't look too happy either. So something has happened to these components here. And the same thing with the same component on the other socket. So check this out. It has been ripped off. There is some damage to BC59 here too. That definitely looks like mechanical damage. But this is fixable. I just need to find out what those components are. So if you have one of these boards, I'd be very grateful if you could have a look at these components and let me know what I should order. So apparently there is going to be a repair video of this board, and I found another missing component. So check out BC24 here. That component has been ripped off, and this is where the heatsink latches on with a metal bracket. So I'm pretty sure someone ripped this component off while mounting a CPU. And the same component on the other socket here. But aside from that, the only thing I could find was one bulging cap here. And these are Jackon branded. And I'm pretty sure these caps are not identical to the caps I had on my original board back then, because I'm pretty sure the caps on my board were green. I don't remember the brand, of course. So I wonder if this board has been recapped. Let me see if I can find any date codes. And I think I did find a date code. And something a bit odd, because this is a Nikkor cap. And if I'm correct, it was made in 2013, week 28. So this board has been at least partially recapped back in 2013-ish. Well, we haven't quite reached the bottom of the pile, but I have to pack my bags now and we're off on a road trip. I would like to end this video by saying thank you to my patrons. If you want to support me too, you will find the link in the description below. Also special thanks to David for donating the deck. And last but not least, thank you for watching, like, subscribe, leave a comment, and I'll see you next week.